Hello, Algebra 1. Let's go ahead and take care of QM3 Part 2. I promise this video will be faster. That last one had a lot of wordiness to it. So let's go ahead and knock this guy out. Let's get right into it. Creating and solving equations. And what we're trying to do here, it says you can use what you know about writing algebraic expressions. Remember, algebraic expressions, so not an equal sign. And algebraic means we got some variables in there to write an equation that represents a real world situation. Suppose Corey and his friend Walter go to a movie. Each of their tickets costs the same amount, and they share a frozen yogurt that costs $5.50. The total amount they spend is $19.90. How can you write an equation that describes the situation? So let's go ahead and take a look at this. So what we're going to look at is identify the important information. There's a word in here that indicates that we have an equation. That word is this one right there. That word is. The word is, well, let's do it. I like capital letters, right? The word is tells you that the relationship describes an equation. The word total tells you that the operation involved in the relationship is addition. And if you remember back, that's kind of what we were looking at yesterday, or not yesterday, whatever, part one, right? We looked at those academic words, those math vocabulary words that mean these things. So what numerical information do you have? Well, let's take a look at this. Right now we've got froyo. We're going to go frozen yogurt. We got our froyo is $5.50. We've got total is $19.90. And what don't we know? What don't we know? We don't know the cost of the ticket. The cost per ticket, because we know that they bought two because it's Corey and Walter. We know that they bought two because it's Corey and Walter, but we just don't know how much those tickets are. So we can have this verbal description here. We're going to use a variable. In this case, we are going to get a little more creative. It's okay here, that's all right. So we're going to choose a name for the variable. In this case, we're going to use C for the cost of the ticket. The verbal description is twice the cost, or 2 times the cost of the ticket, or tickets in this case. Twice, that's of a single ticket. Twice the cost of one ticket. I want to make sure I use the correct vocabulary here. Twice the cost of a ticket plus the cost of froyo. There's our frozen yogurt, right? Equals totals $19. Oh, equals $19.90. So now what we can do is write an algebraic expression for the quantity, and then put an equal sign in this case. We're going to do a numerical or algebraic. And then we're going to make this equation be, we've got 2 times the cost of a ticket, or 2C, plus the cost of the frozen yogurt is equals $19.90. So it says here, how do you use a verbal model to write the equation for the situation described? We just take what they are. We use the math vocabulary and put that into an equation. We got 2 separate expressions that are equal to one another. We have a numerical expression here, which is 1990, and we have an algebraic expression because it's got a variable, that 2C plus 550. All right, let's go ahead and move right on here. It says, we're going to move on. I'm going to ignore that other part, that other reflection question. But we've got creating and solving equations involving the distributive property. Ooh, there's that distributive property again. So this one's pretty interesting in my eyes. Okay, it says Aaron and Alice are bowling. Alice's score is twice the difference of Aaron's score in 5. Difference and twice. I'm going to highlight those. Remember, underline important parts, right? Twice, we know that indicates a multiplication of 2 times. Difference, if you go back and look at that, means, yes, you in the back. Yeah, subtraction. Very good. There's nobody here. It's okay. Subtraction, right? So twice means multiplication. Difference means subtraction. Of Aaron's score in 5. Ooh, so we got some there. And the sum, there's where we go. We got our addition right there of their scores is, oh my gosh, it's like we're just writing these things. It's written for us. Is our equal sign 320. Find each student's bowling score. So let's take this one part at a time, right? We know if we add Aaron's and Alice's score, we get 320. So what I'm going to do is, this is all here. That's fantastic. We know equals 320. We got 2 people with bowling scores. We've got Alice and we've got Aaron. So Alice, we've got Aaron. So Alice's score is twice the difference of Aaron's score in 5. So Aaron, his score, we're just going to call A. Okay. I've got Aaron's score is A. Alice's score is twice the difference. So I've got to do the difference first. The difference of Aaron's score in 5. So I've got Aaron's score in 5, and it's twice this difference. Remember, I have to do that difference first. I know it looks weird, but just think about how this means in real world terms, okay? Twice the difference of, I have to do the difference first, I have to do my subtraction first, then multiply. If I have to do that in some kind of order of operations, that indicates I need to have parentheses. Okay, so if I add Alice's and Aaron's scores together, I get 320. In other words, I've got A plus 2 times A minus 5 equals 320. Well, yeah, we can solve for this. We know how to do the distributive property. A plus 2A, 2 times A. This is essentially 2 times negative 5, so minus 10 equals 320. We need to simplify like terms. I've got things with A's, so this would be 3A minus 10 equals 320. And now we have a 2-step equation. It's like everything we've been doing is leading up to this point, because it has, because that's how I planned it. Here we go. We're going to add 10 to both sides. So 3A equals 330. Divide both sides by 3. And A equals 110. Yay, 110. Okay. What does that even mean? Well, what was A? What was A? Let's go and take a look at this real quick. What did we say A was? A was, oh, Aaron's score. Okay. Aaron's score is 110. Alice's score is 2 times the difference of his score and 5. So what we got to do is plug A in where it is. So this would be 2 times 110 minus 5, 2 times 105, which is 210. If I add 110 and 210 together, I get 320. And we knew that the sum or the addition of their scores was 320. There we go. Does that answer make sense? It absolutely makes sense. We've got Aaron's score, we got Alice's score, good to go. All right, here's one that's gonna be fun because I gotta flip back and forth to this one, but that's okay. We're gonna read it together and then we'll take a look. It says, Mari, Carlos, and Amanda collect stamps. Carlos has 5 more stamps. More. Ooh, if you go back and look at that word, what's that mean? Person in the back. Actually, I'm pointing at a microwave right now, but hey, microwave, you said that's addition. Addition. And Amanda has 3 times. Oh, 3 times. 3 times. That's going to be 3 times. Multiplication. Oh, I'm not going to put the X there. Multiplication. I'll just put MULT out here. Okay. As many stamps as Carlos. Altogether, they have 100 stamps. Altogether, that means if I added them up, I'm going to get 100. Find the number of stamps each person has. So we're going to write that verbal description. We're going to take the time to write that verbal description. Let's go ahead and do that. We're going to have to keep flipping back for a minute here. It's on a weird thing here. What we're going to do, we're going to choose a variable for the unknown quantity, and we're going to write the equation to model it, right? We're going to take S, and we're going to say that's the number of stamps that Mari has. Carlos, it said, how does Carlos compare to Mari? Mari, not Marley. Carlos has 5 more than Mari. So Carlos has 5 more than Mari. S plus 5, because the number of stamps Mari had was 5. Amanda has 3 times as many stamps as Mari. I'm sorry, 3 times as many as Carlos. My bad. 3 times as many as Carlos. Well, Carlos had, let me write this S. Write this 5. Carlos has this many. He has S plus 5. So Amanda has 3 times that. 3 times S plus 5. And if I add all of these things up, I should get to 100. So if I add Mari's stamps, so this is Mari, plus Carlos's stamps, S plus 5, I'll write his name here, and then Amanda's, 3 times S plus 5. If I add all those together, I would get 100. In other words, what we got to do, we got to do some distribution, some simplifying, and then solving. Let's go ahead. Yeah, we'll just rewrite this. I'm going to do it over here. I'm going to select this S plus S plus 5 plus 3 times S plus 5 equals 100. So the first thing I'm going to do, I'm going to take that distribution and go ahead. I've got S plus 5 plus 3 times S plus 3 times 5 equals 100. We need to collect our like terms. I've got 1, 2, 3, 4, 5 S's, and 5 plus 15 is 20. So 5S plus 20 equals 100. Hey, it's another 2-step equation. It's like I planned this to happen. We know how to solve by subtracting 20 from both sides. So I get 5S equals 80. Divide both sides by 5. And S equals, let's see, 16. Great, yay, 16. What does all that mean? What was S? What was S in the first place? Well, S was the number of stamps Mari has. So Mari has 16 stamps. Carlos has, what did we say? Carlos had 5 more than Mari. So if I add 5 to 16, I get 21. And Amanda has 3 times as much as Carlos. If Carlos has 21, if I multiply that by 3, I get 63. Let's make some sense, right? Because in total, they're supposed to have how many stamps? Yes, marker board in the back. Yes, 100. They need to have 100. Does 16 plus 21 plus 63 equal 100? Well, let's see here. 63 and 21 is 84. 84 plus 6 is 90, plus 10 is 100. And from what I've been told, 100 does equal 100. Here's a really good question. We're just going to look at this first one here. Would a fractional answer make sense in this situation? And to me, I'm just going to go around and say it, right? There are cases when fractional times make sense. Like you can have part of a pizza. But does it make sense to have part of a stamp? I don't think so. So in this case, would a fractional answer make sense? And in this case, no. Because having a part of a stamp in a stamp collection, unless it's some super rare thing like I don't even know about, that would be something that just wouldn't make sense. So a fractional answer, in my opinion, would not make sense in this case. All right, let's go ahead and take a look at here. Oh yes, Write and solve an equation to solve the problem. A rectangular garden is fenced on all sides with 256 feet of fencing. The garden is 8 feet longer than it is wide. Find the length and width of the garden. Okay, we can do this thing, right? This has actually got it nice and set up for us. So go ahead, pause right here, and then we'll come back and talk about it. Okay, hopefully it paused. Here we go. It's fenced in on all sides with 256 feet of fencing. So if I go all the way around, what do we call this? What do we call this chair? Chair over there, what do you say it was? Perimeter. Perimeter, fantastic. The perimeter of the garden is 256 feet. So if I add it all the way around, I'm going to get 256 feet, right? And it says it's 8 feet longer than it is wide. So this is W plus 8. This is my W, my width. So if I start here, if I go down right here, that is a length of W. So I've gone W plus, if I go down here, this is W plus 8 plus W feet plus W plus 8. Now, if you know anything about a rectangle, and I think you know a few things, you know that the perimeter is twice the width times twice the height, and plus twice the length. Whew, let me try that again. Twice times the width, twice times the length. So in other words, I could have said 2W plus 2 times W plus 8, and these things would mean the same thing. And in total, the perimeter gives us 256 feet. So what should I do here? I need to distribute. Very good. Distribute through here. 2W plus, well, 2 times W is another 2W, plus 2 times 8 is 16, equals 256. What should I do here? I think it makes a lot of sense to collect like terms here. 2W plus 2W is 4W plus 16 equals 256. And now what do we have again? A two-step equation. It's like I planned these things. 4W plus 16 equals 256. I subtract 16 from both sides. I have 4W equals 240. I divide both sides by 4. And W is 60. Yay! We're not done. Because the question says find the length and width of the garden. We know the width is 60 feet. Don't forget units. But we know the length is W plus 8. The length is W plus 8. So that would be 60 plus 8, or 68 feet. So we got our length, we got our width with units, and now we are done. Okay, here's what we're gonna do. I'm gonna hit pause on that. We're gonna make it a part 3. We're gonna do a part 3 of this video, and that's okay. I want you to do the problems that you can do based on what you got here. There'll be a part 3 of the video. We'll move on from there. Everybody have a great day. Talk to you later.